performance testing. There are a lot of types. Okay, the very first type is the load test. Okay, some people in some companies call this as a peak load test as well. Okay, they will add a word peak before that. Okay, they feel good about it, so they will add a peak load test. Most of the companies use the term load test itself. Okay, whether it's a peak load or a load test, it's the same thing. And the first thing that you need to understand is this is a mandatory test. Okay, so this is the first test that you do when you completed the script, and in the PTLC you move into execution phase. This is the first test that you do. And before this test, there is one more test that you do, which is a shakedown test. I've already told you. Some people call this as a trial test. Some people call this as a mock test. Some people call it as a smoke test. Okay, but we used to call it as a shakedown test. And anybody in the class remember what was the shakedown test about? Anybody in the class remember what was the shakedown test or this mock test or the smoke test about? What is it? Probably in the third class or the fourth class we have discussed. Still remember? Very important interview question. Shakedown test. Okay, so wonderful, Ken. Wonderful, Ken. This is more like a mock test, okay, which is not run with the complete users, only 10% of the users, and it will not be run for 1 hour, probably 15 minutes of the time. And what is the purpose? The purpose of the test is to check if my performance testing environment is good, my tool, which is the LoadRunner, is good, which means that the LGs are up and running, the controller is working fine, my data is right, my scripts are good, my scripts, you parameterize in the script, so the parameterization data is right. All this you wanted to check, so you don't want it to run a load test right away. First you done a trial test. Okay, just before you buy a car, you do a trial run. Just before you do a main test, which is a load test, you do a trial test, which is a shakedown test. Okay, so that's what it is. So after the shakedown test is done, after the whole scripts are ready, like let's say you have decided that you have to do 40 scripts. Okay, so once all the 40 scripts are created, the first test that you do is the shakedown test. And once that is done, you are ready for the load test. You are ready for the load test. Okay, it is a mandatory test. You cannot skip it, which means that there are some tests in these types of performance testing which are not mandatory, which are optional as well. Okay, this test usually simulate current user load or the peak load. Okay, on the application level test, the peak load on the application level test. Okay, you see, usually the peak load for the application is considered for this test. So what is this peak load? What is this, and how do we relate this to workload modeling? I will tell you now. Watch carefully. Okay. Before I go any further, I just added this slide. This slide I pulled it out from my first class, or I think the third class. Okay. So this is the Mark. Okay. He wants to buy his new car. Okay. He is doing the testing on this new car. Okay. What he has done? Okay. So he went for 1 hour drive with his family. And how many people are there in his family? There are total 5 people on his family. So that is the current peak load. Okay. So all these 5 people are sitting. So the current peak load for the Mark is 5 because there are 5 people sitting. There is 5 people of his family. So all the 5 people sit on the car and he goes for a 1 hour drive. Okay. And while he is going for the drive, what is he caring about? Is the car driving fast enough? Is the car driving fast enough? Okay. So the Mark is not driving alone. Okay. He has some load on that car and the load is 5 members. Okay. Which is the current peak load for the Mark. Okay. Now we will decide what is the current peak load for our application. Okay. So for our application. So the application that I have taken is something like an Amazon. Okay. Which is a shopping website. Okay. And as you can see here, I have taken the workload modeling that we have done in the initial class. During the workload modeling days, you remember guys, this is the workload modeling that we have done. Okay, assuming that this is for Amazon. Okay, Amazon shopping. Okay, online shopping website. Okay, so this is the workload modeling that is done by you guys. If you remember, I have given this as an assignment. Okay, as you can see here, okay, we have only 4 scripts or 4 business processes. What are those? Purchase item, cancel item, window shopping, check transaction history. All these 4 of them. Okay, purchase item, cancel item, shopping, window shopping, and check transaction history. Okay, so these are the business process I have. Okay, or the scripts that you have created, and the transaction per hour. Okay, how many transactions, how many purchase transactions are happening per hour? 12,000. Okay, 12,000 purchase transactions are happening for every 1 hour. Okay, so this statistics is taken for 1 hour. Okay, and that too peak hour. We already know what is a peak hour, right? We already know what is a peak hour, right? When you have the maximum load on the application, when there are maximum people using that application. So for that peak hour, instead of saying 1 hour, I'll just say peak hour. So these statistics are taken for 1 hour. So you see, in 1 hour, how many purchase transactions has happened? 12,000. How many cancel transactions has happened? 10,000. Window shopping, how many have happened? 6,000. Check transaction history, how many has happened? 4,000. Total, how many has happened in that 1 hour? Irrespective of which business process it is, 32,000. Okay, so we have total 700 concurrent users. So we have divided these concurrent users across this business process. Okay, so this one, the first one has 263 concurrent users. Second one, okay, has 218 concurrent users. Window shopping 131, check transaction history 88. So the one thing that I want you to keep in mind here, guys, this 12,000 purchase transactions is done by how many concurrent users or how many virtual users? 260. So each virtual user is doing how many transactions per hour? Okay, how many transactions? Each one is doing how many? 12,000 divided by 263. So each virtual user is doing approximately 45 purchase transactions. 45 purchase transactions. Each concurrent user. This is all we have discussed as a part of our workload modeling. That's why I'm going little fast, but I'm giving this background again because you will see how I'll relate this background to our performance test. Okay, you see, these 263 of these virtual concurrent users are running 12,000. So each one is doing how many? Close to 45 transactions. And how we did do it? First, it will run a purchase transaction, then pacing, then a purchase transaction, pacing, purchase transaction, pacing. Like this, 45 of them each virtual user will do. Virtual user will do, one will do 45. Virtual user, out of this 263, virtual user 1 will do 45. Virtual user 2 will do 45. 3 will do 45. 4 will do 45. 263rd will also do 45. How? Between there is a pacing. It will wait for how much time? 68 seconds in between before it will kickstart the next purchase transaction. Okay, if you are putting that in a notepad, okay, so these purchase transactions that we are talking about, okay. So virtual user 1 will run the purchase transaction, okay, will run one purchase transaction, okay, will run out of this 263, I am talking about only one, will run how many? A purchase item, then there is a pacing time. How much is the pacing time, guys? 68 seconds. Okay, it will not do anything. Then again the same virtual user will run one more purchase item transaction. And how many like this it will run? How many like this it will run? We have calculated it will do 45 of them. 45 of them. So 263, 12,000 divided by 263. Each virtual user is doing how many? 45. So 1, 68 seconds pacing. 2, 68 seconds pacing. 3, 68 pacing seconds. Like this, 45th transactions. 45th transactions. Okay, so like this there are. Okay, so you see now I have done the same thing. You see purchase order, how many of them are there? So 263 are doing 12,000 transactions finally. So 1 is doing how many? 12,000 divided by 263. Okay, 263 are doing 12,000. Simple math. If one concurrent user will do how many? 45 transactions, close to 45 transactions. Okay, close to 45 transactions. Okay, so you see there are four business processes: purchase order, cancel order, check transaction history, shopping. Purchase order, cancel order, window shopping, check transaction history. Okay, and purchase order how many? Purchase order, purchase item how many? 263. Purchase order or purchase item is same thing. Okay, so purchase order or purchase item 263. So we have 263 here. You see 263. And cancel order how many? 280. So 218. So I've drawn a graph for that. Check transaction history how many? 88. I've drawn a graph for that. And window shopping how many? 130. Okay, so whatever you have in the workload modeling, the same thing has been put down here. Okay, overall you add all these virtual users. How many? 700 concurrent users are there. Out of these 700, 263 will be continuously running purchase order, 700 will be running cancel order, 88 will be running check transaction history, and 131 will be running window shopping. Okay, so now you see 700 is the peak load. In my mark example, what was the peak load? 5. All the 5 people are sitting on the car going for a 1 hour drive to check the speeds. In my application now, how many? What is the peak load? 700. Why we are calling this peak load? Because this statistics which is pulled is for the peak hour. This statistics which we have pulled for the peak hour, based on this transactions per hour, I have arrived at this concurrent users. So definitely this also relates to the peak hour or the peak load or the maximum. Okay. So now you do the test with this 700. You do the test with this 700. Okay. And one more thing. Okay. This I'll consider out of these 700 users, I'll consider one user. Okay. So one user, let's say, is running the purchase order. Okay. So simple question I'll ask you. Just now I told you, but the same question I have asked you. So this virtual user out of this 263, one virtual user has run this purchase order transaction. Okay. Or executed this purchase order script that you have created. Okay. It has executed the purchase order one time. Okay. After it has executed, this virtual user will not do anything, or will it do something? Simple question. Okay. This one user has executed this purchase order script for the first time. After it is done, okay, will it keep quiet and then it says, okay, my job is done, or will it do anything? Will it do further anything? Does it do any other job? It has run only once. It has run only once. The purchase order has been executed only one time. So after that time is done, so what does it do? What is the next thing that it will do? Okay, perform the next task or the next transaction. Or in simple words, what it will do, once it has executed this purchase order, it has executed this purchase order script, it will wait for the pacing time, and once it is waited for the pacing time, again it will run the purchase order transaction. Again it will run the purchase order transaction. Like this, how long it will run? Is there a time period? It will run for 1 hour. Not only this virtual user, every single virtual user, all the 700 of them will run for how many hours? 1 hour. Okay, will run for how many hours? 1 hour. So my peak load test or the load test will be for 1 hour. Will be for how many hours? 1 hour. Okay. Now the same thing we will watch here. The same thing we will watch here. Okay. That's what I have put down here. Usually the test will run for how many hours? 1 hour. So now we'll start with the graphs, guys. Okay. On the x-axis, the scenario elapsed time or that 1 hour that we are talking about. The test execution time. In our language, test execution time, which we have agreed that it will be for 1 hour. Okay. So that I am putting it on x-axis. Okay. So typically the test will run for how many hours? 1 hour. Test will run for how many hours? 1 hour. Okay. On the y-axis, we'll assume the number of concurrent users. Here, the maximum that you have is 700. Okay. Now watch very carefully. Okay. I'll give you the option. All these virtual users are immediately they have started. All these 700 of them together they have started. You know, out of these 700, some are doing window shopping, some are doing a purchase order, some are cancelling the order, some are doing something else. Okay. So all of them, irrespective of whatever they are doing, all of them have started at once. Okay. This is the time period. You see on the x-axis you have time period right at the 0. You are starting the test. As soon as you started the test, all of them immediately have started. Okay. and all the users have run it for how many hours? 1 hour. Let's say this is 1 hour. This is 1 hour. Let's run it for 1 hour. And once the 1 hour is done, all of them have stopped at once. Okay, all of them have stopped it at once. Okay, this is a 1 hour test. 1 hour test. 1 hour test. So you see, all of them have started at once. Okay, all the 700 without any gap. Immediately as soon as we started the test, all of them became active. All of them continue to do their work for 1 hour. Out of these 700, let's say we will take one user. First it will do purchase order, then pacing, purchase order, pacing, purchase order, pacing, purchase order, pacing. Like this for 1 hour is doing. Similarly, all the 700 of them are doing the same thing. Okay. Once they are done for 1 hour, immediately all of them have stopped. Okay. So this is my option. This is my option. Okay. Now option 2, one by one slowly. You have started the test. In the first minute, like 5 users have started. In the second minute, 5 more users have started. In the third minute, the remaining 5 have started. Fourth minute, after you have started the test, the remaining people have started. Fifth minute, the remaining people have started. Slowly, one by one, all of them have started. And this is the time period. Let's say after 15 minutes of time, so let me, okay, after 15 minutes of time, okay, after 15 minutes of time, all the users have started. Okay, now after 15 minutes into the test, now all the 700 users have started. Now once all of them have started, it will run a 1 hour test. You see, 1 hour test is a mandatory. However you have started, 1 hour test is mandatory. And once the test is done for 1 hour, you have, instead of stopping all of them at once, slowly one by one, all of them have stopped. This is, again, that's a 1 hour test, and this is option 2. Okay. What we use in the real world, option 1 or option 2? Let's go with the 2. 2 is what will be used in the real world. Okay. 2 is what will be used in the real world almost for every single scenario. Okay. So you don't want to start all of them at once. Imagine in the real world, in Amazon. Okay. Now is at 7 o'clock. Okay. Now exactly at 7 o'clock, people don't talk to each other and say that, oh, it is at 7 o'clock. Now we need to log in because we all need to log in at once in Amazon. People don't talk to each other in the real world and say that right at 7 o'clock, exactly at 7 o'clock, let all the 700 of us will try to log in and start using the Amazon. That will never happen in the real world. People join whenever they want, people leave whenever they want and all that. Okay, so this scenario will never happen in the real world. Like, all the 700 of them will start exactly at the same point of time. Okay, will never happen. Okay, so there is no point doing that. So now the next question is, are we not wasting the time? If we are going with the option 2, we are wasting this time and we are wasting this time. You see, our time is for 1 hour. We wanted to run it in the test for 1 hour. Now look at the downside of option 2. You see, my line of interest is this 1 hour. Okay, my line of interest is this 1 hour. So we are wasting this 15 minutes of time, and let's assume this is also 15 minutes of time. We are wasting this 15 minutes and we are wasting this 15 minutes. Okay, we are wasting this 15 minutes and we are wasting this 15 minutes. So is there an upside? Is there an upside for wasting this 30 minutes of my precious time? Yes. Okay, so had we went for this option 1, you would complete the test in 1 hour. If you are going for option 2, this 1 hour plus 15 minutes plus 15 minutes. Overall test is happening 1 hour 30 minutes. But what is my line of interest? Only 1 hour. So I'm wasting 30 minutes. So what is the upside of wasting this 30 minutes? Downside is wasting that 30 minutes, but is there an upside? Yes. So what happens is, if you start all the 700 of them at once, the server starts behaving weirdly. Okay, so in the real world that doesn't happen. Immediately all the servers are sleeping. You see, before this time, let's say you have started this time test at 7 a.m. IST. Okay, 7 a.m. PDT. Okay, you have started this test at 7 a.m. PDT. Before this is done in performance testing environment, mind you. Before this 7 a.m. there is no activity in the performance testing environment. Suddenly at 7 a.m. PDT, you have given 700 virtual users. Suddenly there is so much activity. And servers which were sleeping, immediately there's so much activity that you have given to the servers that they might even crash. They might even crash, or they starts behaving weirdly. A lot of error messages you might get until it settles down. It will not happen for the whole 1 hour, but the first 5-10 minutes, all sorts of weird things will happen and the response times will be really high. Okay, so you never go with option 1, I tell you. Okay, that is the reason why. Let it waste this 30 minutes. It's still okay, but slowly start one by one so that the server will warm up. The server will warm up. It's like you started driving the car and this is not a race course. You're going to the 5th gear immediately. I know in US it's all automatic cars, but somebody who has driven in India or in your respective countries, automatic cars are not that common. Okay, it's a manual or stick shift cars is what we call it. So if you're driving a stick shift car, okay, or in India it's a gear car. So you don't go to the 5th gear or 4th gear immediately. You start with the 1st gear, then 2nd gear, 3rd gear, 4th gear, and then 5th gear. Then the car will behave the way you wanted it to. Or even in the automatic cars, you don't go to 100 miles per hour just like that. Okay, you slowly increase it until it goes to the 100 miles per hour. Similarly over here as well, before this 7 a.m. PDT, there's no activity on the server. Immediately at 7 a.m. PDT, you're putting so much activity, some naughty things will happen on the server. So you don't want that to happen. So you slowly add one user after another user until you reach that 700. Now you do that 1 hour. However, you're going to do that 1 hour. Now you do that 1 hour. And once it is done, slowly stop one by one. No issues, no hurry. Okay. But when we consider the report, ideally filter this report for this 1 hour and send it to the client, because 1 hour is your priority. 1 hour is when you are running it with maximum users, which is 700. Okay. And in this period that you see here, there is a special name for that, which we call it as a ramp up. And this period, which is our line of interest, which we really care about, we call it a steady state. As the name studies, it is a steady state with continuously with 700 users. And ideally, the report will be sent for this 1 hour. You need to filter the report for this 1 hour and you need to send it. Because this ramp up is only to facilitate this steady state. And the ramp down is you don't want to stop all of them at once. Again, sorts of weird things will happen. So this facilitate the test happens smoothly. You have this ramp down. So when you send the results, typically this 1 hour, filter it and send the report for this 1 hour. That's what people will do it. Okay, and then you slowly, and then this portion is what we call it as a ramp down. So this portion is ramp up, steady state, and ramp down. Going forward, we will use these terms very, very often as we can. Okay. Now, you see, load test we have done with how many? 700 concurrent users. How did we get this 700 from? From workload modeling. How did you get this 700 from? Workload modeling. Yeah, the client will give you, but from the workload modeling sheet also, you have this 700. Okay. So, I'm just relating this test to the workload modeling that you have done. Okay. The workload modeling, it didn't go waste. Okay. So, why this load test? Now, this is what is a load test. 700 is the peak load, user load. You ramp up to 700, run a test of 1 hour and you ramp up. So, why this 700? Why this load test? Okay. The load test is done to ensure that the application of the test is stable and handle expected peak load once the application is deployed. Once the application is deployed, or once the application goes live, or once this application is made available to these end users, okay, what you want to ensure with that load of 700, which will happen in the real world, will the application work fast? Can my application handle this expected peak load? We are expecting these 700 users to be there, concurrent users. So if this expected peak load happens in the real world, what will happen to my application? Will it work fast? Okay, you wanted to check it before the application goes live, and that's how you can check it using this load test. Using this load test, you will be able to check that. Okay, it is a very, very important test and a mandatory test. By doing this, now if this test passes, what can you go tell your client? Saying that, oh, now your application Amazon is going online and at once in a day, in 1 hour in a day, you will have 700 concurrent users, and in that peak hour as well, the application will work fast enough. And if the application work fast enough for the peak hour, definitely it will work for any other hour, other 23 hours. Okay, so it can handle the peak load, definitely it can handle the lesser load. So the lesser whole load will be handled, but the peak load will also be handled. Your application will work fast during the peak hour. Don't worry, is what you can tell to the client if your load test passes. If your load test passes, it's a mandatory test, always done at the starting. Okay, after the shakedown, this is the first test that you will do. Okay, once this test has passed, now you will go to the next test, which is the stress test. Okay, which is the stress test. As the name suggests, you are stressing the system. When will a person be stressed? When there is a lot of work, you will be under stress. Or yes. So similarly, okay, our application as well. Okay, you will stress so much that it breaks down. Okay, you stress so much that you break down. Okay, so let me show you the graph, then I'll show you all that sentences that I have written. Okay, again the same thing. This is the scenario elapsed time or your test execution time, number of concurrent users. You see, this was for the load test. The first line is for the load test. Now the second line is for the stress test. So here you start, keep increasing. This is when you have a 700 mark. Okay, you don't stop at 700. This is the expected peak load. You keep going, keep increasing the users, until you find the breaking point. Breaking point means this application can handle only certain number of users. Okay, so we have designed this application to handle how many? 700. Now you are increasing. Let's say 2000. It has handled 1500. It has handled. You went all the way till 2000. 2000 is way too much load for this application. It is an unexpected load, and what happens at 2000? The server stops responding to the request. Go back to our hotel server. He can serve, let's say, 3 tables or 4 tables. Now you have increased 1 table. It could still handle. You increase 1 more table. It could still handle, but the people will be served little late. You add 1 more table to that server guy. He could still handle, but the serving time will increase. But you keep adding. At certain point of time, the server says, oh, this is way too much load. I need to walk back and forth. I will not be able to handle this, and the hotel server will break down. Okay, he will grab a cup of coffee and he will leave the hotel because he cannot handle so many tables. There's a certain number of tables a hotel server can handle. Similarly over here as well, there's certain number of users. Okay, there is certain number of users this particular application can handle, but you keep increasing until the system breaks. How do you know the system has broken? You will get all error messages. Every single transaction will error out. Okay, the test won't stop, Siraj. The test won't stop. The test will continue, but you will continuously get the error messages. The past transaction count will decrease tremendously. Everything will be error. Everything will be a failed transaction, or the response times will be really high. This is when you know that my system has broken. When there are a lot of error messages. Okay, lot of error messages. Let me go back to the text that we have written. Okay, this is the slide that I have skipped so that I can explain it using that graphs. Now let me talk about it with this particular text that I have written. You see, stress test is conducted by increasing the user load gradually until the application breaks. That's exactly what we have seen. Objective of this test is to obtain the breaking point or saturation point. Okay, so when is the saturation point? We need to know about this breaking point or saturation point. Different people call it differently. We used to call it as breaking point, but I heard some people calling it as saturation point as well. Okay, usually once the breaking point is attained, okay, there is a noticeable increase in the errors and there is a big increase in the response times. Okay, the error count will increase. drastically, this is when you know that this is the breaking point. This is the breaking point because this is when the error count has increased drastically. Okay. So now what is the point of the stress test? Okay. So you see that now you can tell to the client that with 700 the performance is very good, but for whatever the reason, the application, the user goes to 1000 momentarily. For 1000, still the application can handle it. The application servers won't go down, but for that fraction of the time when the user count has increased it to 1000, the response times might decrease, but the server will still handle. For a fraction of a time, if there is a spike of 1500 users, like for 2 to 3 minutes, there is a fraction of a time wherein there is a user load of 1500, still the servers won't go down. There is a fraction of a time, there is a spike for 1800 users for like 2 to 3 minutes, okay, in the whole day. For whatever the reason, there is an increase to 1800 for a few minutes, okay. That's what we call it as a spike, okay. Still the application, the servers will not go down. But for whatever the reason, okay, suddenly the user count or the user load has increased it to 2100. Okay, or let's say the breaking point is 2000. For whatever the reason, it has increased it to 2000. This is when the server may go down. This is what you can tell to the client by doing the stress test. Now this is why a stress test is done. Okay. Again, this is the second test that we do as soon as our load test passes. When do we go for the stress test? Only if the load test passes. This is when you go to the stress test. If the load test is not passed, then there is a bottlenecks. You send it to the developer. He will fix the bottlenecks. Then you come back and do the load test again. Okay. And this time around it passes. Now you go and execute the stress test. Now the next test is endurance test. Okay. Very popularly, it is called as soak test. In my projects, they call it as soak test. But formally, they call it as endurance test. Okay. This test is performed for longer period of times. For how long? I used to run it for 8 hours. Some of my friends used to run it for 1 day. And I've seen some, I heard there was a soak test run for, or endurance test run for 3 days as well. Okay. And this is done with expected user load or less than the expected user load. I used to run it with less than the peak load. Okay. Let's take the example of Mark only. He wants to buy this new car, nice new car. Okay. He is not done with the testing yet. He wants to do one more test, that is for the stability. You remember, performance testing is testing the application for speed, stability and scalability. We are talking about stability. Okay. So what did our Mark do? He wants to do one more test, this time around test for stability. So he went out, his family is for 4 people, but this time around for testing the stability, he went out with 3 of his family members. So totally 4. So all the 4 people are sitting in the car. You see, this is less than the current peak load, which is 5. Math family is how many? 5 people. But he's going on this test drive with how many? 4 people. And it's a long test drive, 3-day test drive. Okay. So what is the purpose? Before he starts, Mark starts, he has to come out with the agenda, right? As to what am I testing for? He wants to test, is it when I drive long, are the speeds good enough? Is there a decrease in speed? Like, you know, in the first day, let's say the speeds are attained is 100 miles per hour. Second day also, it should be same. Third day also, it should be same. So you never know, the car engine might heat up, the tires might go flat. We never know what all can happen. So he wants to test that there is no decrease in the speeds. Okay, if he's continuously driving for 3 days. That's exactly what you're doing. That's exactly what you're doing with your application as well. So you see, performance testing is testing the application for speed, scalability and stability. Speed we have seen, that is the first test, which is the load test. Now we are looking at the stability part. So that is nothing but endurance test or soak test. The test for stability is nothing but endurance test or soak test. You see, the endurance test you don't do with 700 users, you do with 500 users. Okay, usually 70 to 80% of the peak load is considered for the endurance test. Okay, now you do a long test. assuming that this is 1 hour, okay, let's say this is 8 hours test. I know statistically if this is 1 hour, this is not 8 hours, but I didn't have a space, so assume that this is 8 hours. So you do a 8 hours test, and once you are done with the 8 hours test, again you ramp down. So for endurance test, there is a ramp up, there is a steady state ramp down. The steady state is for 8 hours, or it could be 1 day, or it could be 3 days. The client will tell you how long it is. The client will tell you how long it is. So if you're continuously, let's assume it is for 3 days, you're continuously running for 3 days. What is my agenda when I'm doing the test? What is that I'm careful about? In the first day, first hour, whatever was the response times, the speed, or whatever was the speed of the application, or whatever was the response times, should be same in the last hour of the last day. Okay, the last hour of the third day also, the response times for all the transactions should be same. Okay, in the first day, first hour, whatever it was, same thing you wanted to see in the last day, last hour. Then you say that your application is stable and your endurance test is passed. When you can say your application is stable, the response times is constant throughout these 3 days. Okay, first hour, whatever it was there, last hour, last day, same thing, it should be there. This is when you can say the application can be stable. Okay, so the next question is there a times when my application could not be stable? Okay, when will be the times my application will not be stable? When you have some performance bottlenecks like memory leaks, connection leaks, and all that. Okay, especially when you have some memory leaks in the application, this is when your application will not be stable. When I say the application is not stable, in the first 1 hour of the first day, the response times are good, but as we proceed further, in the second day, the response times deteriorate a little bit. The third day, the further deterioration happens, and all that. Okay, watch carefully. What is this memory leak? And very important interview question. Okay, so they might ask you, did you do endurance test? Yes. Then immediately ask you, what is the purpose of doing endurance test? Then you say that to catch the memory leaks, or to identify the bottlenecks like memory leaks. Then they will immediately ask you, what is memory leak? Now I will explain what is memory leak. Okay, let's say this is your memory. Okay, so memory means RAM. In any system or any server, any computer, any desktop, any mobile phone, you have 3 important things. One is the processor, one is the RAM, one is the hard disk. Okay, so RAM and processor will decide the performance. RAM and processor usually will define the performance. So here I am concentrating on the RAM or the memory part of it. Okay, or RAM or memory part of it. So I'll tell you, when you have a program, running, okay, a small program you have written and it is running, usually it will be running from the RAM itself. The program will run from the RAM itself. When the program is running, and this program will have variables as well. The program will have some variables or objects. If it's an OOPS concepts, it is objects, but let's limit it to for C program. You have written some C program and you have declared some variables. Okay, you have declared some variables. Let's say you have declared a variable called int I is equal to 1. This is the declaration you have done. Int I is equal to 1. We know how to declare and how to initialize. In a small program that you have written, you have declared this int I is equal to 1. Now, my server or the computer has to run this program. So, as soon as it executes this line, what does my server will do? A small piece of memory is allocated to this I and 1 is stored inside that. A small piece of memory is allocated to this I. This piece of memory is allocated to what? I, and this one is stored in that particular memory location. Okay, small piece of this memory is allocated to this I and 1 is stored in that. Okay, like this, there are multiple variables that are declared in the program. Every time a variable is declared, a piece of memory is allocated to that. As the time continues, lot of variables will be declared, which means that lot of memory has been allocated of this available memory, lot of memory is allocated. When you are starting, let's say, okay, it is a 4 GB memory or 4 GB RAM, okay, RAM, okay. After 1 hour of test, lot of memory has been allocated to lot of variables. It would become 3 GB, let's assume, okay. Overall it is 4 GB, but 1 GB is used, so you have only 3 GB left, okay. Then 1 more hour, 1 more GB is being allocated to all these variables, only 2 GB is left. And then after some time only 1 GB is left, and after some time 0 GB is left. When there is 0 GB, now again the program has to run, then a variable has to be declared, a piece of memory needs to be allocated to it. If a piece of memory cannot be allocated to it, then the variable can never be declared. If the variable can never be declared, then the program can never run. So in other words, the server has hanged up. In other words, what the people will say, the machine has hanged up or the server has hanged up, because there is no more memory for the new variables coming in. Ideally, what they will do, for the same reason, what they will do, once you are done using the variable, they will deallocate it. Once you are done using the variable, you will deallocate it so that the same memory can be allocated to the new variable coming in. Once you are done using this int I is equal to 1, what do you have to do? You have to deallocate it. In C program, you use a piece of code like free. Okay, you use a piece of code like free, so that this memory which is allocated to this I will be freed up, and the same memory can be allocated to some other variable. Okay, so in case if you don't free or flush out, okay, you don't flush out all these allocations, what happens over a period of time? You don't have any more memory that will be there, so that new variables can take it. So this condition wherein this memory is being decreasing over a period of time, okay, and eventually it can become 0. That condition is nothing but memory leak. So memory locations or memory is allocated to this variable. As soon as it's done, it should be removed, which means that it should become 3 GB. Again, from 3 GB it should become 4 GB. It should become 3 GB, and as you free it up, again the memory should increase. So it should increase and decrease, increase and decrease, increase and decrease, increase and decrease. Whenever the memories has been allocated, it should increase. Whenever you free or flush out, it should decrease. Memory has been allocated, it should increase. Whenever you free, this is the used memory, right? Or used memory is 1 GB, right? 1 GB. So from 4 GB it is coming to 3 GB. Used memory is what? 1 GB. So as the allocations is done, it will be increasing by 1 GB. And as you are flushing it out or freeing it up, the used memory should become 0. Then again, as the more allocations is done, it should become 1 GB. And you are flushing it out, freeing it up, it should become 0. Like this, it should oscillate. But it should never increase like that. It should never increase like that, because if it keep increasing like that continuously, then there will be no more free memory that will be there at all. There is no more free memory that will be there after some point of time. This condition wherein you are not freeing up the memory and continuously the memory is being used up, this condition is nothing but memory leak. Memory leak. So I have explained this memory leak in terms of C language, but the same thing applies for Java programming language as well. Over there, we don't talk about variables, we talk about objects. There, they create objects, a piece of memory is allocated to the objects. And here in the C program, you have to specifically write a piece of program like free. But in Java program or programming language or .NET programming language, we need not have to write this extra piece of code. There is a program which runs, okay, which we call it as garbage collector. There is a program which automatically runs, okay, which we call it as garbage collector. Okay, this is the heap memory. In the whole of the RAM, we divide into different portions. One of the portion is the heap memory. Okay. Well, yeah, garbage collector is a program which is scheduled regularly for every 5 minutes, even for every 1 minute, or even for every second. Depends on the developer. He will schedule it. So what does this program comes? This program will watch each of these objects and say whichever is unused, whichever is unused, it will take away and clean up the memory. So this garbage collector program will exactly do the same thing as this free code will do. Whatever the objects which are stalled or not used for a while, it will clean up. Okay, so there are multiple GCs, major GC and minor GC. I'll try to cover that in the analysis part if the time is there. Okay, so this program called garbage collector will come and take away the unused objects so that it will free up the space. Whether you're using this program or garbage collector program, they are doing the same job, but the only thing is in C programming language we don't have a program called GC, but in OOPS concepts programming language like .NET and Java, you have garbage collector which will come out and take away all the garbage, which will collect all the garbage. In other words, unused objects or unused variables, it will collect and clean up the memory so that there is more memory available for my next coming in objects. Okay. What kind of errors we will identify? What kind of errors we will see if the memory leak occurs? Can somebody tell me? Okay, when we run the endurance test, if the application is not stable or if there is a memory leak, what will happen to the response times, guys? Over a period of time, the response times increases. First 1 hour it will be 2 seconds. In the next day it will be 3 seconds. The next following day it will be 4 seconds. The response times will increase, and this is how you identify if there is a memory leak or not. Or there is an easier way to identify. You look at a graph called memory utilization graph. Okay, this is the time, 1 day, 2 day, 3 day, and this is the memory utilized. What is this? How much of the memory is utilized? So what ideally should happen? The memory should increase, and when the garbage collector will come and take away, the memory should decrease. The memory utilization will decrease. Then memory will increase because there is a lot of objects and variables getting created and the memory is being allocated, and then again the garbage collector will clean up all the remaining memory. The memory should decrease. So it should oscillate something like this. But what will happen if there is a memory leak? It will go, but it will not clean up the entire thing. If it cleans up the entire thing, it will go all the way here. But what will happen? It will not clean up the entire thing. It will clean only partial of it. Then again it will go. It will clean a partial of it. It will go, clean a partial of it. As we go up, the graph will go only up. It will not come down. This is when you know. This is when you know there is a memory leak. This is when you know there is a memory leak. Okay. Okay. Now we will go to scalability test. Okay. So let's go to where is my mark example? Okay, hang on. Let's go to my mark example. Then I'll go back to those slides. Okay. So Mark is not done with his testing of the car yet. He wants to do one final test before he can buy the car. What is he doing? The test for future load. What is the current family? Mark, 5 people. But he knows he will have kids at some point of time, 3 years down the line, 4 years down the line. So he will have kids. So he's thinking, oh, if I have the kids, will my car support that? So for the future load, Mark is planning for it. So he had his nephew, sons come over, and 3 of them. So all these 5 people or 8 people will sit in the car. He will go for 1 hour drive. And what is he looking for? Is my car driving same fast enough? Fast enough? The same thing. Whatever with 5 people, it should be same with 8 people as well. This is what Mark wants to do. And he is going for 1 hour drive only. Not for 8 hours, 1 day, 3 days. Okay. So this is nothing but the scalability test, guys. Okay. So it will be done for the future growth or the future load down the years. Okay. For example, this is the NFR that is given for us. What is the NFR? There is a 50% growth, user load growth in the next 1 year. How much? 50% growth. Growth in the user load in the next 1 year. So now is what? 2008 March, in 2009 March, 19 March, 2018 March, 2019 March, the user load will be what? 700 plus 50% of it, which is what? 1050. The user load will be 1050. So 50% growth means 1050. 700 plus 50% of 700 is what? 350. 700 plus 350, 1050. So you do the test with 1050, not with 700. So you have a ramp up again, 1 hour test as usual, and you have a ramp down. But this test is, how is it different from the load test? You are looking at performance testing is testing the application not only for speed and stability but also for scalability. And that is the reason why you are doing this scalability test. You're doing this scalability test. And why do we do this scalability test, guys? Okay, why? If it is happening in 1 year from now, it is happening 1 year from now, why do you want to do the test now? Why don't we do the test in 2018 March only? Why are we doing the test? Sorry, 2019 March only. Why are we doing the test in 2018 March? If this load is happening in 2019 March, why are we doing right now? Because we have exactly, let's say the load test has passed, but the scalability test has failed. Scalability test has failed. Now there is a problem. It could be lack of infrastructure, it could be so many things, but whatever it is, the developer have 1 year to fix it. Because this load is happening when? 1 year from now. So you either have to scale up or scale out, or infrastructure increase, or there is some issue with the database connections, whatever it is, you have so much time to decide. You have so much time to figure out what needs to be done for that. So it is good. If the scalability test passes, now you can go and tell the client that it will not only run fast now, but it will run fast 1 year down the lane when the user load will become 1050. Very important test. But this is an optional test. Okay, endurance test is mandatory, stress test is mandatory, load test is mandatory, but we used to mark this as optional. But it depends on your client whether you wanted to take this as optional or mandatory. But we used to mark this test as optional. Okay, now the fifth one is the volume test. What is it? The volume test. Okay, so what is the purpose of the volume test? Okay, it is a load test except that the huge data is populated in the database. It is exactly like the load test. Same ramp up, same ramp down, same steady state, 1 hour test with same 700 users, everything same. Only thing is data in the database increases. Okay, so let's say this is the current database. This future database sometime happen in the future. You see, there are only 1000 registrations now. Okay, but sometimes in the future it will not be 1000, it could be 100,000. Okay, so you increase the current database to the future database. Whatever in your performance testing, it will be the current database. You increase the data in the database. Okay, that will happen sometime in the future, 1 year from now or 2 years from now or down the years. Okay, now once the data has been increased to that future database, now you do the load test with 700 users, exactly with 700 users, nothing less, nothing more. Okay, and ideally the response time should not deteriorate much. Okay, there is a little deterioration that happens, but the deterioration should not be really significant because of the increase in the data in the database. So this is the purpose of the volume test. You see, this is the volume test. Again, it is exactly like the load test. Okay, it is exactly like the load test, which is done with 700 users. Again, this is an optional test because that will happen sometime in the future. Okay, what is the purpose of the volume test? Some people, they call it as a data volume test as well. Okay, volume test, data volume test and all that. Okay, purpose of the test is to check if there is a change in the response times with increased database volumes. Since you have increased the database, you wanted to check if the response times has been affected or not. It will get affected, but it should be very, very marginal. It should not be significant. Okay, so